Hello students, in this video we are going to study statistics for class 11. You have already studied the measures of central tendency which are mean, median, mode in the previous classes. In this video we are going to study the measures of dispersion. You have already studied the measure of central tendency which gives it the middle value, say mean, median or mode. Now a measure of dispersion will tell you to what extent your data is scattered from that middle value. Correct? That means suppose you are having the average of say 2, 4, 6, 8, 10. The average is 6. So if I study the measure of dispersion, I can just say how much my data is scattered from that middle value. For example, suppose you are having the scores of two students for 10 tests. The marks for 10 tests are given for both the students. If both the students have the same mean or average value, how will you decide who is the better one? You study the measure of dispersion. The person who is having less dispersion means the less scattered data, he is considered more better or more consistent. Why? Because most of the time he is getting his scores near the middle value. But the person whose data is more scattered, that means the measure of dispersion of variability is more, that person is less consistent. Before going to the important formulae, let us first discuss types of data. Let us recall that you can have discrete data, which means the data can take only certain values. For example, if you are having the number of people, shoe size, etc., you can have 2 people, 5 people, but you cannot have 2.5. So this type of data is called discrete data. It takes certain individual values. Continuous data that can take any value within a given range. For example, height, weight, time, etc. You can have the weight of students as say 40 kgs, 40.5, 45, 50.5. It can take any value within a given range. You have ungrouped data. That means data which is given as individual points. For example, marks of students in a monthly test. So suppose 50 students are there, the marks of each student are given as individual data points. Then you have the group data. Group data means the data that is given within ranges. Now the group data can be grouped discrete data or grouped continuous data. That means if you are having discrete data, you can group it, and also if you are having continuous data, you can group it. For example, if you are having the number of cars owned by people in a city, then suppose if you are having 0 to 2 cars, suppose the city has 100 families, 0 to 2 cars, say 80 families, 3 to 5 cars, say 10 families. That means the data which is over here is discrete, but I am grouping it. So it is called discrete data. Similarly, you have grouped continuous data. For example, the height of students can be grouped as 150 to 160 centimeter, 160 to 170 and so on. So here the heights can take any values within the given range. So this is the example of grouped continuous data. Now the first measure of dispersion is the range. Range is the difference between the highest and lowest value from a data set. So this is a very raw measure. This will just tell you how much totally your data is scattered. Suppose there are 5 students in a class with the given heights, then the range of heights will be the highest height means 200 minus the lowest height, which is 150 centimeter. So the range of the data values which is given is 50 centimeter in this case. Note that the range for group data can be found by subtracting the lower limit of the lowest class from the upper limit of the highest class. That means suppose the height of students is given in the form of group data. Suppose these 3 classes are there. Then what is the range? The range is the upper limit of the highest class, which is 180 centimeter, minus the lower limit of the smallest class, which is 150 centimeter. So total range over here is 30 centimeter. The advantages are it is very simple and easy, a very raw measure. Obviously the disadvantages are it is affected by the extreme values. That means it is sensitive to outliers. Outliers means the values which are very far away from the main values. In this case, the range will not give you a proper idea. Second is it does not use all the data, only the highest and lowest values it uses. So it is not good for large data sets. Also from this you cannot estimate the measure of central tendency. Now let us understand the second measure of dispersion, which is mean deviation. As the name suggests, mean deviation or mean absolute deviation is the average deviation of a data point from the mean, median or mode of the data set. That means you have a measure of central tendency which can be say mean, median or mode, and from that how much your data is deviated or scattered you can study by mean deviation. Now since the average is the central value of the data, some deviations might be positive, some might be negative. That means suppose the average, or say here if we take the average as mean, for example, suppose the mean of 10 observations is any number 5. So some observations can be more than 5, some observations can be less than 5. So when you take the deviations or the difference of the value from the mean value, that difference can be either positive or negative. So if they are added just like that, then their sum will tend to cancel each other effect, because suppose the observations are say 2, 4, 6, 8, 10. Then suppose I am having 6 as the mean. So if I take 2 minus 6, and that is minus 2, and if I take 8 minus 6, that is plus 2. When I add both of them, the effect gets cancelled out. So we cannot just take it as it is. So we take the absolute values of the difference instead of taking the exact difference. The formula over here is the mean deviation formula for ungrouped data. Now again I am saying mean deviation can be either the deviation from the middle value, which is the mean, or it can be the deviation from the middle value, which is the median. So the formula for mean deviation ungrouped data from the mean is x bar. That is equal to summation of xi minus mod of xi minus x bar upon n. Summation I running from 1 to n, absolute value of xi minus x bar by n. Similarly, for ungrouped data, if the mean deviation is taken from the median, suppose m stands for median, then that is equal to summation mod or absolute value of xi minus m upon n. Similarly, mean deviation for group data. Group data, you have the xi values and the corresponding frequency. So mean deviation from the mean is sigma fi into mod of xi minus x bar upon n, where capital N is the total frequency, sigma f. Similarly, mean deviation from the median m is sigma fi mod of xi minus m upon n. We are going to do examples to understand these formula later. Regarding the advantages of mean deviation, it is not much affected by outliers, means by the extreme values, because all the values are taken into consideration. Now disadvantages or limitations. In a series where the degree of variability is very high, the median is not a representative of central tendency. Thus the mean deviation about median calculated for such a series cannot be relied. Because you can find mean deviation with respect to mean and mean deviation with respect to median also. So if you are taking mean deviation with respect to median, then obviously it will not represent the whole data. Second is negative positive signs are ignored and we just take the absolute value. So actually it leads to inaccuracies. Also, mean deviation is calculated on the basis of absolute value and therefore it cannot be subjected to further algebraic treatment. That means if I want to find something else based on that, then it will not give a proper idea. It is not rigidly defined and can be calculated with respect to mean, median and mode. So here the middle value which you are taking can be mean, median or mode. So it is not defined rigidly. Also, most of the sociological studies rarely use this data. The important measures of dispersion, variance and standard deviation. First, let us see the formula for the same so that you understand what is done to get the variance and standard deviation. Variance and standard deviation for ungrouped data. If you are having ungrouped data, the variance symbol is sigma square. That is equal to 1 upon n sigma xi minus x bar square. That means what you are doing is you are taking the sum of the squares of the distances from the middle value. Xi minus x bar means the distance from the middle value, and you are taking the square and then you are summing it. So you are taking the sum of the squares upon n means the average. So basically what is your variance? Variance is the average sum of the square of the deviations. Correct? Now when you take the square root of the variance, you get standard deviation whose symbol is sigma. So you are just taking the square root of variance, which will give you standard deviation. Same way, if you are having discrete frequency distribution, you have Fi with Xi. So the formula is variance is 1 upon n, where n is sigma Fi. Variance is 1 upon n sigma Fi into Xi minus x bar whole square, and standard deviation is the square root of variance. For continuous frequency distribution, the variance is 1 upon n sigma Fi Xi minus x bar whole square. Similar formula like the discrete distribution over here. Here you are going to have classes. That you can write in another form also after simplification as 1 upon n square n into sigma Fi xi square minus sigma Fi xi whole square. See, this formula will be useful when you are doing the examples for the purpose of calculation. The square root of variance is again standard deviation. Now there is also a shortcut method to find the variance and standard deviation. Like you had the assume mean method for finding the mean, same way by using the assume mean method we can find the variance and standard deviation. So in this case we assume that capital A is our assumed mean, and let the deviation yi is equal to xi minus assumed mean A upon the class length h. So let yi is equal to xi minus A upon h. Then in this case our formula for variance is h square upon n square n sigma Fi yi square minus sigma Fi yi whole square, and the square root of variance is standard deviation. These formula will get very clear as soon as we start with the examples. We have just seen the formulae for variance and standard deviation and know how it is calculated. So if we want to define, we can say variance is the average squared deviation from the mean, while standard deviation is the square root of variance. We have just now seen in the formula. Now, standard deviation is a measure of how much dispersed your data is in relation to the mean. And suppose if you are having say low standard deviation, then it shows that the data are more near or more clustered around the mean. Why? Because you know standard deviation is a measure of dispersion. Dispersion means if the data, how much data is scattered. If that value is small, means the data is less scattered. It is more near to the mean. So low standard deviation shows that the data is very near to the middle value, and high standard deviation shows that data is more spread out or more scattered. Now second thing is why standard deviation is considered the best measure of dispersion. Because by seeing the formula we know that variance involves the sum of squares. That means whatever answer you get, that will be in the form of the square. So it will not give you an exact idea of the deviation. Only when you take its positive square root, you will get the answer in form of the unit of original data. For example, suppose I am having the variance for the height of students. So it will be in the units of say centimeter square. Original data height is given in centimeter, but we are getting the variance in centimeter square. So it will not represent the actual data. But if I take the square root of variance, I will get standard deviation, which will be in the actual units of the data. It will be in centimeter. That means your standard deviation will be same, will have the same units as your random variable. So it is considered the best measure of dispersion. Some points to understand. If each observation is multiplied by a constant k, the variance will become k square times the original variance. We will understand this with the help of an example later on. Adding or subtracting a positive number to or from each observation of a group does not affect the variance. Standard deviation is sensitive to outliers. That means even if you are having a single outlier, even if you are having a single extreme value, it can significantly increase the standard deviation because all the observations are considered in this formula. The standard deviation value is low or close to 0 when the data sets are similar to each other. Just now we have seen if the standard deviation is low means it is more near the middle value. So if two sets, we can compare two sets also using its standard deviation value. If there are say two batsmen A and batsman B, if both are having the same mean value, how will you decide who is the better one? Then what do? You find the measure of dispersion, say standard deviation. The batsman who is having standard deviation low is considered more consistent because his values are very near to middle values most of the time. But the batsman who is having a greater standard deviation will be less consistent. Also, one more thing to note, the value of standard deviation cannot be negative. We have seen this by the formula. It is the positive square root of variance. Now we will solve the examples to understand the concepts. For the first example, the data is given. You have to find the range, mean deviation about median, mean deviation about mean, variance and standard deviation. This is an ungrouped data which is given. You know mean is sigma xi upon n. Total of all the observations upon total number of observations. So in this case the mean is 14. First we will find the median and then we can use it afterwards. You know that when you want to find the median, if the number of observations are odd, then it is just the n plus 1 by 2th observation. But here the number of observation is 12. So median is the average of which two observations? N by 2th and n by 2 plus 1th. So here median is the average of the 6th and 6 plus 1 means 7th observation. So median is 13.5. First measure of dispersion is range. Range is simply the highest observation minus lowest observation. So that in this case is 18 minus 10 which is equal to 8. So range is 8. Next we have to find the mean deviation. First mean deviation from mean and then mean deviation from median. Mean deviation from mean formula is sigma xi minus x bar upon n, where x bar is the mean. Just now we have found the mean was 14. First of all, just list the data. You are having 12 observations. The individual data values are xi. Find xi minus mean. That means say first observation 13. 13 minus 14 is minus 1. 17 minus 14 is 3 and so on. Then you have to take the absolute value in the formula. That means you have to ignore the signs. So when you take the absolute value and sum it, the total is 28. So first thing is we find mean deviation from mean, sigma of xi minus x bar which is 28 upon total number of observation which is 12. I have given the formula and which values I have taken so that you understand it properly. So mean deviation from mean in this case is 28 by 12 which is 2.33. Next we find the mean deviation from median. So here the same formula but you have to do xi minus median. So in this case I have directly taken the absolute value because now I think it is clear absolute value means you ignore the sign. So first observation say 13. What is the median? 13.5. So 13 minus 13.5 is minus 0.5. Take the absolute value, it is 0.5. In this way list down all the absolute values x minus median and sum it up. You are getting that equal to 28. This is a special case in which you are getting both the sums as 28. It doesn't happen every time. So mean deviation from median in this case is 28 upon 12 which is again 2.33. Next we find variance and from that we find standard deviation. Formula for variance, sigma square is equal to 1 upon n, sigma xi minus x bar whole square. So now make a column for xi minus x bar means mean and square of that. That means the first value of xi is 13. 13 minus what was the mean? 14. That is minus 1. Square of it, that is 1. Similarly, list all the observations, sum it up. X minus mean whole square is 82. So put it in the formula of variance. It is 82 upon n, 82 upon 12, which is 6.833. Standard deviation is nothing but the square root of variance. So square root of 6.833 is 2.614. So what are your answers? Your answer is mean deviation from mean is 2.33, mean deviation from median is 2.33, variance is 6.83 and standard deviation is 2.614. Example 2. Find the mean deviation about the median. Here the data given is in the form of xi, fi. Correct? So here the data which is given is a discrete frequency distribution. To find median, we first find the cumulative frequency. You know that for finding the mean deviation about the median, you need to find the cumulative frequency. In this type of data, median is that value which corresponds to the cumulative frequency in which n plus 1 by 2th observation lies. That means it is the value of xi for which your cumulative frequency is equal to or just greater than n plus 1 by 2. So first thing is we will find the cumulative frequency and from that we will find the median. Let us see in the chart. To find the median, just list first of all xi, fi values, then we find cumulative frequency. How do you find it? For the first one it is 3, then you go on adding the previous frequency. So 5 plus 3, 6 plus 8, 7 plus 14 and last 8 plus 21, 29. Always remember that if you want to check whether it is your total is right or not, the last cumulative frequency will always be equal to n. Now what is the value of over here n? N is 29. What is n plus 1 by 2? It is 30 by 2 or 15. So just see the value of xi for which your cumulative frequency is 15 or more. So corresponding to, see in the cumulative frequency column, cumulative frequency just more than 15 is 21 and corresponding xi value is 30. So your median is 30. So first of all we have found the median which is 30. Now for the mean deviation about median, the formula I have given over here, sigma fi into mod of xi minus median upon n. So first column you make for xi minus median. Xi 15, median 30. So 15 minus 30 and take the mod value, remember absolute value. So that is 15. 21 minus 30, absolute value is 9. And so on, find that value, multiply all these values by corresponding fi. So for the first one it is 3 into 15, 45, then 5 into 9, 45, 6 into 3, 18 and so on. Take the total of fi into mod of xi minus median which is 148. Now put in the formula for mean deviation of median. It is that 48 divided by sigma fi which is 29. So 148 divided by 29 is equal to 5.103, which is the mean deviation about median. Example 3. Find the mean deviation about mean, variance and standard deviation. These three measures you need to find. The data over here given is in the form of group data. Height in centimeters and the number of children is given. So first of all, since you need to find mean deviation about mean, you first need to find the mean. What is mean? Sigma fi xi upon sigma fi, where xi is the midpoint of each class. Say first of all list the data and list your classes. Afterwards find the midpoint of each class. So for example 95 to 105, midpoint is 105 plus 95 by 2 which is 100. Next class 105 plus 115 by 2, that means it is 110. In short, you find the midpoint of each class which is your xi. After that you find what is f into x, that means fi into corresponding xi. So for the first class 9 into 100, 900 and so on. For mean, it is summation of this fi xi values, which is 12530 upon total frequency, which is 100. So mean is 125.3. Next, you find mean deviation about mean. The formula I have given over here, sigma fi into absolute value of xi minus x bar upon n. So next column you make for absolute value of x minus mean. For the first observation, 100 minus 125.3 and its absolute values, that is 25.3, and so on. Find all the x minus mean absolute value. Multiply these values by the corresponding frequency. For the first class, 9 into 25.3, that is 227.7, and so on. Total of these values is 1128.8. Next thing is for mean deviation about median, it is this total divided by sigma f, that is 100. So mean deviation about median, MD if we call it, it is 1128.8 upon 100, which is 11.288. Mean deviation about median is 11.288. Next we find what is the variance. Variance formula over here is 1 upon n sigma fi xi minus x bar whole square. So again over here you find xi minus x bar, already you have found out, just square it. Like for the first observation, it is 25.3 square, which is 640.09, and so on. That is your xi minus x bar square. Multiply that by the corresponding frequency. So for the first one, it is 640.09 into 9, which is 5760.81. In this way, find for all the classes. Sum these values. So when you sum these values, it is 18891. So your variance is 18891 upon 100, or it is 188.91. I have purposely written the values so that you know how this variance is obtained. Standard deviation is just the square root of variance. So square root of 188.91 is approximately 13.74. So answer is mean deviation about mean 11.28. Standard deviation 13.74, variance 188.91. Next is how to find the median of group data. Now, the formula to find the median is L plus n by 2 minus C upon F into H. So first thing is over here, we have to find cumulative frequency. What is cumulative frequency? Cumulative frequency of a class is the sum of frequencies of that class and other preceding classes. The median class is the class whose cumulative frequency is just greater, or that means nearest to n by 2. What is n? N is sigma f, total frequency. L is the lower limit of median class, n is the total frequency, f is the frequency of the median class, C or CF, anything you can write. It is the cumulative frequency of the class preceding the median class, and H is the class size. Let us take an example to see how to find the median of group data. We just now recalled how to find the median for group distribution so that we can use in this example. Next example, calculate the mean deviation about median age for the age distribution of 100 people. So here age is given in form of classes and the number of people. So for this group distribution, first we will find the median. First of all, just take care, here the classes which are given are not continuous. So always if you want to apply the formula for the grouped frequency distribution, first you need to make the groups continuous. Always remember this for any example. So 16 to 20, how will you make a class continuous? You just subtract 0.5 from the lower limit and add 0.5 to the upper limit. For each class, it will become continuous. So first class 16 to 20 will become 15.5 to 20.5. Next class 21 to 25 will become 20.5 to 25.5. In this way, your data has now become continuous. Now you can use our formula. Now what is xi? Midpoint of each class. So first we have listed the midpoint of each class, corresponding frequency. Then to find the median, we first find the cumulative frequency. Again 5, 6 plus 5, 12 plus 11 and so on. Again I am repeating the last cumulative frequency will be equal to the total if your calculation is right. Now next, how will you find the median? Just see what is n by 2. N by 2 over here is 100 by 2, which is 50. See the class which has cumulative frequency 50 or just more. So the class 35.5 to 40.5 has cumulative frequency 63, which is more than 50. So your median class is this. How will you find the median? To find the median, the formula is L plus n by 2 minus C upon F into H. Our median class is 35.5 to 40.5. So L is 35.5 plus n by 2 is 50 minus C means cumulative frequency of class before the median class. That is 37 upon F. F means the frequency of the median class, which is over here 26 into the class length. Class length is 5. So putting all these values, we get the value of median as 38. Now to find the mean deviation about median, the formula over here is sigma fi mod of xi minus median upon n. So next column we make for absolute value mod of xi minus median. First class xi is 18, median we have found 38. So 18 minus 38, the absolute value of that is 20. Similarly for all the classes. Multiply this value by the corresponding frequency. For the first class 20 into 5, next class 15 into 6 and so on. Take the summation. In the formula, what is the mean deviation about median? This summation upon n, that means 735 upon 100. So that is 7.35. So the answer for this example is mean deviation about median is 7.35. Example 5. Find the mean, variance and standard deviation using the shortcut method. Now over here we will use the shortcut method. When the data values are big, you can use the shortcut method, or if it is given in the question. For using the assume mean method or the shortcut method, first you find out a variable called yi, which is xi minus assume mean upon class length h. First of all, the classes are given over here. We have listed the classes and the corresponding frequency. Then we have found the midpoint xi. Like for example, 70 to 75, midpoint is 72.5 and so on. Next we find out what is yi. Yi is xi minus assume mean upon h. Now first of all, take some value as the assume mean. Generally you take the midpoint of a class which is in between as the assume mean, so that it makes the calculation easy. So over here we will take 92.5 as the assume mean. So for the first class, xi minus a upon h, that means 72.5 minus 92.5 upon 5. Class length is 5. So that will give you minus 4, and so on. You find out all the yi values for all the classes. Then you find out yi square, that means just square this term. Next column is fi into yi, means corresponding frequency into yi. 3 into minus 4 minus 12, 4 into minus 3 minus 12 and so on. After that, the next column, multiply yi square by f. So 3 into 16, 4 into 9 and so on, and make the totals of each of them. Now first of all, mean. The formula for mean is a plus sigma fi yi upon n into h. Here n is 60. So it is a assume mean, which is 92.5, plus sigma fi by I, that is 6 upon 60 into 5. So putting those values, you will get the mean as 93. So first thing we found is mean is 93. Next thing we find the variance. The formula for variance is by the shortcut method is h square upon n square n into sigma fi yi square minus sigma fi yi whole square. So put the values. H square means 25 upon n square means 60 square 3600 into n, which is over here 60 into 254 minus square of 6, that means minus 36. Putting these values, you will get the variance as 105.58. Next, take the square root of variance, that is standard deviation. Square root of 105.58, that is 10.275. Remember, since if you are allowed the calculators, you can directly find it. Otherwise, you have to use the square root method to find the square root. So we have found in this case mean as 93, variance as 105.58 and standard deviation is 10.275. Next, different type of example. The mean and variance of 7 observations are 8 and 16 respectively. If 5 of the observations are 2, 4, 10, 12 and 14, find the remaining 2 observations. Now first of all, let the missing observations be x1 and x2. The formula for mean is sigma xi upon n. So that is 2 plus 4 plus 10 plus 12 plus 14 plus x1 plus x2 upon 7, and this mean is given to us as 8. So after simplifying, we get x1 plus x2 is equal to 14. Let this be equation 1. Now what is the formula for variance? Variance is 1 upon n sigma xi minus mean square. So this variance is also given to us as 16. So 16 is equal to 1 upon 7 into 2 minus 8 square plus 4 minus 8 square plus 10 minus 8 square plus 12 minus 8 square plus 14 minus 8 square plus x1 minus 8 whole square plus x2 minus 8 whole square. Why? Because our mean is 8. Now on simplification, what do you get? 112 minus 108 is equal to x1 minus 8 whole square plus x2 minus 8 whole square. Simplify this. So you will be getting 4 is equal to x1 square plus x2 square minus 16x1 minus 16x2 plus 64 plus 64. Take out minus 16 common. In bracket you have x1 plus x2. But x1 plus x2 is 14 from first equation. Just put that value. So on simplification, you will get x1 square plus x2 square is equal to 100. Let this be equation 2. So let us solve our two equations, x1 plus x2 is equal to 14 and x1 square plus x2 square is equal to 100 for getting the two unknowns x1 and x2. First thing is square the first equation. So x1 plus x2 whole square is equal to 14 square, which is 196. x1 square plus x2 square plus 2x1 x2 is 196. In that, put your x1 square plus x2 square as 100. So what do you get? 2x1 x2 is equal to 96. Now take x1 minus x2 whole square. This is also equal to x1 square plus x2 square minus 2x1 x2. So put the value of x1 square plus x2 square as 100 and 2x1 x2 is 96. So what do you get? x1 minus x2 whole square is equal to 4 or x1 minus x2 is 2. Now solve the equation 1 and 3. That means solve x1 plus x2 is equal to 14 and x1 minus x2 is equal to 2. Simply add the equations. You will get x1 is equal to 8. Putting that value, you will get x2 is equal to 6. So our missing observations are 8 and 6. Now example 7. The mean and standard deviation of a group of 100 observations were found to be 20 and 3. Later on, it was found that 3 observations were incorrect, which were 21, 21 and 18. Find the mean and standard deviation if the incorrect observations were omitted. Omitted means removed. First thing is mean sigma xi upon n. Sigma xi upon n, total how many observations? 100. So n is 100. This mean is given to us as 20. So first equation we get is sigma xi is equal to 20 into 100, which is 2000. Formula for standard deviation, root of 1 upon n sigma xi minus mean whole square. And when we take the square of that, we get variance. Now it is given that the standard deviation is 3. So 3 square is equal to To remove the square root, we are taking the square. 1 upon 100 into sigma of xi minus mean. Mean is 20 whole square. Simplify this. Bring 100 on the left hand side. So 900 is equal to sigma of xi minus 20 whole square. So that is sigma of xi square minus 40xi plus 400. 900 is equal to sigma xi square minus 40 into sigma xi plus 400 into sigma 1. Correct? This is how you solve it. Sigma xi square, keep it as it is. Sigma xi from equation 1, put it as 2000. Always remember sigma 1 is n. Why? Sigma 1 means sigma I running from 1 to n. You have to add 1 n times. So that will give you n. So in short, remember, if you are having a constant term, say 400, when I apply sigma to it, it is 400 into sigma 1. So 400 into n. Sigma 1 is always n. But n over here is 100. So 400 into 100. Simplifying this, you get sigma xi square as 40900. Let this be equation 2. So what we have obtained till now, the old or the incorrect summation sigma xi is 2000 and the old or the incorrect sigma xi square is 40900. Now we have to remove the incorrect observations which were 21, 21 and 18. So now total number of observations will become 100 minus 397. For finding the correct mean, we have to do the correct sum upon the total number of observations now, which is 97. How will you find the correct sum? Old sum was 2000 minus, subtract the three values which you have removed. So 2000 minus 21 minus 21 minus 18 upon 97. The correct mean will be now 1940 upon 97, which is 20. So first thing we have found, correct mean is 20. To find the correct variance. Now variance formula 1 upon 97 into sigma xi minus mean the whole square. Remember, here we are getting the mean as 20 only. Correct mean is also 20. So we have taken that. Correct? So 1 upon 97 sigma xi minus 20 whole square. Simplify it. It is sigma xi square minus 40 sigma xi plus 400 into sigma 1 upon 97. Again sigma 1 over here is n, but n now has become 97. So this is sigma xi square minus 40 into, put the correct value of sigma xi, which is now 1940, plus 400 into 97 whole divided by 97. So what we have got is new or the correct sigma xi square is equal to the incorrect xi square minus 21 square plus 21 square plus 18 square. See, now why we are doing this is to find the correct xi square. From the incorrect xi square, we have to remove the squares of the observations which we have omitted. So first of all, for getting the correct standard deviation or the correct variance, you will need to find the correct sigma xi square. So that is equal to 40900 minus the square of these three terms, which is 441 plus 441 plus 324. In short, your correct sigma xi square is 39694. Let this be equation 5. Now to find the correct variance, it is 1 upon n, means 1 upon 97 into 39694 minus 38800. Why? Because this is from our equation 4 and equation 5 which we have just obtained. Correct? So putting these values, we get the correct variance as 9.2165. And the correct standard deviation is square root of that, which is 3.036. Now example 8. The mean and standard deviation of 6 observations are 8 and 4 respectively. If each observation is multiplied by 3, find the new mean and new standard deviation. Now for the old mean, it is sigma xi by n. So n is 6, sigma xi by 6. This is given to us as 8. Old mean is given 8. So we get sigma xi is equal to 8 into 6, which is 48. Let this be equation 1. The new mean will be now, each observation you are multiplying by 3. So 3 into x1 plus 3 into x2 plus 3 into x6. So it is sigma 3 xi upon 6 or 3 into sigma xi upon 6. But what is sigma xi? It is 48. So 3 into 48 upon 6, which is 24. So the new mean is 24. Now note here very carefully that if each observation is multiplied by 3, we see that the mean is also multiplied by 3. 8 into 3, 24. Now for standard deviations. The old standard deviation, putting the values in the formula, root of 1 upon 6 xi minus x bar whole square. This is given to us as 4. Squaring both the side, we get the old variance 1 upon 6 sigma xi minus old x bar was 8 square, that is equal to 4 square, which is 16. So now simplifying, we get sigma xi minus 8 whole square is 6 into 16, 96. Let this be equation 2. So now the new variance in this, what we are doing is 1 upon 6 sigma, instead of xi we are taking 3xi, multiplying each observation by 3 minus the new mean, which is 24. So 1 upon 6 sigma of, take out 3 common, xi minus 8 whole square. So 3 square into xi minus 8 whole square. That 3 square bring outside. So it is 1 upon 6 into 9 into sigma of xi minus 8 whole square. From the second equation, put this value as 96. So it is 9 upon 6 or 3 upon 2 into 96, which is 144. So the new variance is 144 and the new standard deviation will become root of 144, which is 12. So now note this very carefully. We have seen this observation that if each observation is multiplied by a constant k, the mean will be multiplied by k and the variance will become k square times the original variance. What was the original variance? 4 square, which is 16. Multiply that by 3 square, which is 9. So 16 into 9, 144. New variance has become 144. Example 9. Find the mean and variance of first 10 natural numbers. Now for this we are going to use two formulas. We know that sum of first n natural numbers is given by n into n plus 1 by 2 and the sum of the squares of first n natural numbers is given by n into n plus 1 to n plus 1 upon 6. So we will use these two facts. Now mean means sigma xi upon n. So sigma xi means n into n plus 1 upon 2 divided by n. N gets cancelled, so this is n plus 1 by 2. Hence, the mean of the first n natural numbers is n plus 1 by 2. Now, from this also we can get that sigma xi upon n is n plus 1 by 2 or sigma xi is over here n into x bar. Why? X bar is sigma xi by n. So, sigma xi is n into x bar. See, we are writing this as equation 4. We will use it afterwards. Variance formula 1 upon n sigma xi minus x bar whole square. So it is sigma xi square minus 2 x bar into sigma xi plus x bar square into sigma 1 whole divided by n. Sigma xi square from equation 2, n into n plus 1 into 2n plus 1 upon 6 minus 2x bar. Instead of sigma xi from equation 4, can I write that as n into x bar? And the next term, x bar square, sigma 1 is n. N gets cancelled. So, you will get n plus 1, 2n plus 1 upon 6 minus 2 into x bar square plus x bar square. This is equal to n plus 1, 2n plus 1 by 6 minus x bar square. We are just doing the simplification step by step. Now, instead of x bar, put n plus 1 by 2. We have just now obtained x bar is n plus 1 by 2. So put that value. On simplification, you will be getting this as n plus 1 into n minus 1 by 12. So that is n square minus 1 by 12. Hence, the variance of the first n natural numbers is n square minus 1 by 12. So students, class 11 statistics includes the measures of dispersion. I hope it is clear. Please do like and share the video and subscribe to the channel.